Okay. From this symbol, your input will be on your left and your output will be on your right. So this is the output and this is the input. And one more thing, as it is a basic gate, over here, first, as I mentioned, I want to focus on NOT gate. So for NOT gate over here, the minimum input is 1. So you're going to have basically 1 as the input and 1 is for the output for the inverter or a NOT gate, and it will be opposite. And in digital also, as I already mentioned in our first class, we're going to have only 1 0 1 0 1 0 all together, which is it is a binary numbers. So binary numbers will be 1 0 1 0, and there will no casting, which is 0.5, 0.1. In a between there is nothing, so you will only have 0 and 1 as the input. And because of this, you will have only also 1 and 0 as the output. If the input is 0, as it will reverse as an opposite, so the output will be 1. While if your input is 1, it's going to be 0 for the output. Or maybe, as I mentioned, 1 can be on. 1 can be true. Whatever positive term is 1. And that 1 can be also as a high. So if you see a positive term over here, normally it's represented as 1. And 0. 0 is also can be known as off state. And then it can be also as
it's 15 hours.
True. I guess it's wrong. Not wrong. I forgot this term. True, wrong. And what?
False.
Huh, thank you. False. False. And another one is low. So this is sometimes a term that different lecturer will love to use, like maybe on. Sometimes they want to use a true, and sometimes they want to use the high. So over here, this is on not. So if whatever they just mentioned, okay, the input is true, then you know that your output is false, and whatever versa. That is one, which is not. And last time you see also at the previous slide on the active low and active high. If you still remember in our previous slide, there will a bubble over here. If this part is called as an active low, and if there is no bubble, it is an active high. But now you apply it into the gates, and normally we will use this kind of symbol, which is not gate. But sometimes when you going to minimize a combination of circuit, then you will have the method for you to put the bubble version. You will play around with like left or right. So as long as you can differentiate whether you want to apply it on term of active low or active high, or maybe in a gate to represent it as a NOT. As long as you're not confused, then it's okay. Second is your AND gate. Okay, you can see over here there is a lot of input, but the very basic you can have for AND gate is 2 input. You cannot have this kind of AND gate. This is not AND gate, although it's look like similar, but if you have one input only, it's not going to be AND gate. So the minimum of AND gate is 2, and you can have a lot of input for AND gate, but the output will be only 1. So I repeat again, for the AND gate, for the OR gate as the basic gate, the minimum input is 2. And of course, the output will be 1 for all of the gates. So this is the minimum, and you can have maximum whatever numbers that you can have for input, and the output will be only 1. And the condition over here. So you need to remember the condition in terms of sentences. But if you cannot remember in sentences, as long as you know, okay, if only all the input is 1, then your output will be 1. So only, let's say this input A and input B is 1, then the output is 1. The rest, if let's say the input is 1, 0 or 0, 1, whatever, it still remains 0. This is the first condition that you need to know about AND gate. Later on, you will see the truth tables that you're going to apply. Okay, before you go deeper to the gates, as I mentioned, I guess I already mentioned to you, this is 1, 0 for binary. And you have another numbering system, which is the one that you use normal day, which is 0, 1, 2, 3 until 9. So this is decimal numbering, which is base 10. That's why you have 10 numbers, including 0. 0 number we call as 1 until 9 altogether we have 10 numbers. That's why we call it as a base 10. And binary is base 2. Why is base 2? You have only 2 numbers, which is this numbers is 1 and this one is 0 as 2. 0, 1, only 2, so it is base 2. How you justify this? For not, you only have 0 and 1. So how the truth table will look like? So let's say you have the input of A, and the X is your output. Whenever you have A as 0 and A as 1, you cannot have another possibility, right? As I mentioned, you cannot have like 0.5 and so on. So only 2 possibility. So you have only 2 possibility, to the power of 1 equal to 2. So only 2 possibility to the power of n. So you have 1, 2 possibility. If let's say you have input, 2 input, you're going to have to the power of 2. Why I put this 2? Because your n is equal to input. Your input, and the equation will be to the power of n. To the power of 2, you will get 4. So later on, you will have 4 possibility if you have 2 input. Later on, we will see. Now we look into the NOT gate. If your input is 0, your output will be 1. If your input is 1, your output will be 0. This is just a table for you to memorize. But later on you will see that you're going to have like this kind of truth table. Let's say over here is A, and then this X, you're going to have 0, you're going to have 1, 0, 1. So if 0 for A, your output will be here. You will like put it as 1. 1 mean correct. So then if 1 it will be, if it is 0, then it will be 0. 0, it will be 1. And if it is 1, it will be 0. So this is another way for you to draw the truth table. Later on, you will learn how to circle it, and then you will like coming out with your Boolean expression. But just now, no need for you to like headed about this kind of truth table. Later on, you will slowly learn. This one is table for you to memorize. If this scenario, what is the output? If this input, what is the output? Okay, easy for this part. How about AND gate? You already know the condition, and I already inform you to the power of n, which is to the power of 2. Let's say you have this kind of AND gate. So you have 2 input. So you're going to have 4 possibility. What is the 4 possibility of your input? First of all, you're going to have 0 for your A. Let's say you have A, B, X. Okay, this one is for your table, and this one is the symbol. And then this is A, this is B, and this is your X. First of all, you're going to have 0, 0. If A is 0, if B is 0, what will be your answer for X? So this one you're going to see that you only have true if all the condition is true. So means that X is 0. If let's say you have another condition, 0, 1. So your answer will be also 0. Another scenario, you will be have 1, 0, A as 1, B as 0. You're going to have also 0. And another last condition, you cannot have any other possibility. This is a mathematical of possibility. That's why you have another, you have only 4 scenario to the power of 2 because you have to input. So you have here is 1. So only this situation you will get 1, the rest will be 0. So you need to remember this table and this scenario. If only you have 1 for both input, then you will get 1 for your output. So what is basically this one? How you going to like put the scenario? This is basically 0, 0. If you know the numbering system, you're going to know this is base 2 binary. And if you convert 0, 0 using calculator, you pick this as a binary or base 2, you convert, you're going to get 0 for your decimal or base 1, base 10. For 0, 1 over here, the second situation, if you convert, you will get 1 in decimal. 1, 0, if you convert using your calculator, you will get 2. And 1, 1, if you convert in using your calculator, you will get 3. So how basically you can convert it? So this one is like more on mathematical, which is you have to the power of 2, to the power of 0 and to the power of 1. I hope that you know to the power of 0 is what. This one is basically 1. This one is basically 2. So if 0, 0 means 0 times with whatever above here is 2 to the power of 1 is 2, right? So times 2 plus 0 times 1 equal to 0. If you have another condition is 0, 1. So you will get 0 times 2 plus, this one is for you to convert from binary to decimal. You will need also to convert decimal to binary. So over here you will get 1 times 1. Why is 1? Why is 1? 1 is here, and then you're going to times with to the power of 1 or 1 over here. Altogether, this one you will get 0, this one is 1, so that's why you will get 1. If there is another condition, you have 1, 0. 1, 0, you will get 0. You have 1 times to the power of 1 is 2 plus 0 times to the power of 1 is 1 equal to, this one is 0, this one is 2. You get 2. And same goes to last one is 1 times 2, which is 1, 1. This one plus with 1 times 1. Total up in decimal, you will get 3. That's why in your truth table, you will have 0, 0, 0, 1, 1, 0, 1, 1. So in sequence, you can see that it is 0, 1, 2, 3. All together is 4 situation. If let's say you have 3, let's say you have 3 inputs, what your table will be look like? So you're going to have like A, B, and C. So to the power of 3, you will get 8 possibilities. So you will have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. If you convert to decimal, you will get 1, 2, 3, 4, 5, 6, 7. All together add possibilities, and you will have your output. Let's say it is X. So what is your output? If your conditions for AND gate, you will only get 1. For all conditions for your input is 1. So the rest will be 0, 0, 0, 0, 0. So this is how basically it's look like, and when you apply for this, because sometimes whenever you have like this input, you're not going to have the basic things. So if we're given the value A is 1, B is 1, C is 0, D is 1, let's say. So what is the output of X? So you need to know, okay, this is the AND gate, so you're going to apply this scenario. As long as you understand the basic with 2 input, the one that I mentioned, then easy for you to apply. The third basic gate is O. So for the O gate, you're going to have slightly different. You have a curve over here. Not here, but here also. And this is the basic O gate, which is, as I mentioned, similar to AND gate. You need to have minimum 2 input. Then it can be O. It cannot be like this, because this one is only 1 input. So this is the minimum with its 2 input, and there is 1 output. And it's Only true when you have at least one or more input as one or true. So if let's say you have 0, 0, only then you will get 0, but the rest will be 1. So how the table look like? Later on you will see. Okay. So this is basically the truth table, not the basic logic that you need to know in or and not. So if you have this strong fundamentals knowledge, then you can easily apply it in a complex situation. So this is the example that I already mentioned. If let's say you have input 1, your output will be 0. If your input is 0, your output will be 1. So this is how the truth table look like for NOT gate. Okay, now we're going to see for AND gates. This is just the example when you apply and NOT gate into this IC. Okay, for AND gate, you can see over here for the AND gate, if let's say you have input 1, 1, then your output will be 1. If let's say you have the input of 0, 1, you will have 0. If you have a 1, 0, then your output will be 0. And if it is 0, 0, then it will be 0. So basically in together, as we already summarize, this is the very basic truth table that you can understand and you can memorize it. 1, 1, only if all the input is 1, then your output will be 1. Or high or true, whatever kind of positive words can be applied here. Okay, this is an example. So now, hurry, hurry, hurry. Want to check who did not enable their webcam. Aiman, Haikal.
Yes, betul.
Oh, tadi you buka dua kan?
Yes.
Webcam, okay. Sefeldin. Susahnya pronunciation this. Salfidin Ibrahim. Salfidin Ibrahim, I can see that your microphone is on. I cannot hear your voice. Maybe her microphone got a problem. Okay. Aiman Haikal, I want to give you a question, okay? Let me draw and then you need to answer.
Okay.
Excuse me, doctor.
Yes?
Can I go to the toilet for a while?
Yeah, sure can. Afraid you've been kicked. Okay, Aiman.
Yes.
Sorry, it's ugly. Maybe I can use my. I don't want you. I don't want to link to my pen.
Excuse me, doctor.
Yes.
Safeddin just texted me. He says he can't talk. There's
Huh?
something wrong with his mic. There's something wrong with his mic.
Okay. It's okay. I ask Aiman first. What is value of y?
1.
Okay, correct. Thank you, Aiman. Very easy. So over here, if let's say you have 1, 0 for the AND get input, and then you can see your output over here will be 0. And you have another gates to be converted into another output that is going to be inverter. Over here will be 1. So it's depend on your input over here. So I just want to see, I just want to show all of you. This is very simple. Although you say, okay lah, this is quite simple. I can like easier to do. But when you have, let's say you have, after this, you're going to have another AND get, and then you will connect to another there is another different input coming out from C, let's say input 1, and you connect them to another AND gate, and then you have another input D, let's say. So you connect to O gate. So that is the output, and then your output is like maybe go to the O gate and not get, and then this one there is another input. So what is this answer? So that's why from the basic thing, and then you slowly will get the answer, then slowly get the answer. So you're going to be like, when you look, oh, this is very huge in circuit. So you will like, how to answer. So basically it's all from the basic thing. When you combine all together, finally you will get answer. Although you have like 1, 2, 3, 4, 5. 5 input. Lastly, you only have 1 output. As long as you know the operation, it's easy for you to answer. But if you don't have any strong understanding, then it's hard for you to apply. Although you think that it's quite like, wow, too big equation. But basically, it's from all basic things. Next is our OR get. So from our OR get, you can see over here, if you have 1, 1, you have 1, 0, 1, you will have 1, 1, 0, you will have 1, but if you have 0, 0, then it will be 0. So this is the basic truth table for OR gate. And the example where you apply the OR gate for the IC 74332. Now, after you have these 3 basic gates, you can have another gates, which is a combination, but we call it's only one. And you're going to have also exclusive gate. So here, first is our NOT gate. From our NOT gate here, before we can have NOT, of course, we have like direct things. You can see there is no NOT over here. It's buffer, means that whatever in, and you're going to get a similar output, which is up. So it's look like a table differentiation over here. This is true and this is not. When you have the basic buffer, when you have not, then it will be inverted. Same goes to your AND. When you have AND, you can also have not AND. So this is not, this is AND, not AND. Or we call it as NAND get. We not going to call it as not AND, but we call it as NAND get. A combination of not and AND get. So it's basically similar to AND get. You combine with the NOT gate. But instead of you want to draw like this, you can like have the simple version, which is and not going to be NAND get. Similar to AND gate, the minimum you need to have at least 2 input and you can have multiple output. And over here you can see because it's not, it's converter from this end. That's why whatever answer for the output will be also convert. It's easy for you like not to think about conversion, but on top of it, please memorize directly as a single new gate. Okay, NAND gate will be similar like this, and NOR gate will be similar like this. But throughout, theoretically, it is a converter from the OR gate. Okay, it is not too hard for that. And now we look another one more thing, which is these like mathematical terms. But in digital logic, we call it as Boolean expression. We not call it as equation, but we call it as a Boolean equation. So this thing first, before we go to end, go to the buffer and not. Over here, you will have x equal to a. A is your input. So normally we will represent like a mathematical. Mathematical is this part will be your sum, isn't it? Your sum. So in here, in our digital logic, our output will be here equal to whatever input value. So it's also depend on variable. As I mentioned, you can have many variables, possible variables, A until Z for your input and your output. Depend on the question. So let's say our output will be X. X equal to our A for the buffer. But if let's say you have not, you need to invert it. So we put bar over here. We call it as A bar. So this A bar is the inverter for the buffer or A bar. If let's say your A is 1, the value of A bar will be 0. So X is 0. And for AND gate over here, you're going to have A dot B. Normally, this dot is equivalent to multiplication. It's like multiplication going to A times B. And sometime in your exam, in your test, we rarely put this button, dot. We rarely use this. We always like direct put equation like this, because our equation not just these two, but sometimes we have 4. Normally we're going to have 4, or maybe in the equation it will be 3 input, but some part is will be 3, some part will be 4. Okay, I give you example. Let's say you have A B bar plus A. This one is your X. A C D bar plus B C bar plus C D plus whatever want to do. So you can see over here, some part you can see only A, B. Some part there is A, C, D. Some part there is B, C only. But all together, if you have like this, your input will be A, B, C, D. So you're going to have 4 input because you have A, B, C, D. Although you have like plus over here. But I just want to show you that this is what is basically you're going to get later on in your test, in your final exam. So from this basic thing, please make sure you understand first. And we didn't put dot. But plus we will put, which is for all. So there is no dot over here. Please make sure you know if let's say A, B, it equivalent to A dot B. Okay. So over here, this is for N. Whatever input is going to be A dot something. Maybe C dot something, as long as you know this is represent similar input value variable. And for NaN, of course, it's going to be the not version. That's why you're going to have A, B bar. And I give you example, this version is not similar to X equal to A bar dot B bar. Although you can see that it's equal bar, this one. Only maybe it's not continuous, it's similar, but it is not. If you have A dot B bar, it is not similar to A dot B. So that's why you need to also carefully know where you're going to apply the bar. So this one is A dot B bar is for the NaN, if your input is A, B. And this is not NaN gates, because you're going to put, okay, let we play around with how to justify that it is not similar. Okay, for this one, let's say we have A and B as the input, and we have NAND gate, AND gate, and this is our NOT gate. Why I draw it below? A, B. Okay, from here, you're going to see A dot B. What is your answer here? Let's say this one is C. C equal to A dot B. Please assume that it is equal also AB, okay? I just want you to see it clearly, so then I give you an example like this. AB. So after that, you will go through here, go to the NOT gate. So here will be A dot B. After this one, after this C, or maybe you can see over here is C. X equal to C bar. Your C bar, you need to apply all. But for A bar, B bar, the one I mentioned you just now, it will be like this. You have A, and then it will go to bar. This one is A. To get the A bar over here, it will be go through to the not. You have B. You need to go to the not to be a B bar. To get these two to be not over here, multiple over here, we will go to the AND gate. We will get A dot B. A bar dot B bar. So totally it's different. Can see? This is how basically look like for the A, B bar. And this is for the circuit for A bar dot B bar. So although I mentioned over here, sometimes maybe you like confused whether it is continuous or not. It is basically not continuous if the equation is basically shows like this. There is a gap. So in equation, you will see whether it is continuous or whether there is a gap. So just to make sure that you know that is not similar. Second is your O. You're going to have A plus B. So it's like similar thing. You can see this is multiple, right? 0 multiple with 0 will be 0. Whatever you multiple with 0, it will be 0. That's why you will only get 1 if let's say you have 1 multiple with 1. And for this part, it is like adding. You can see over here adding. Then you will say that 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 1 will be 1. And 1 plus 1 in binary. 1 plus 1 equal to 1, 0 in binary, okay? Because 1 plus 1 in binary, you will get 1, 0 or 2. And this is, after this you're going to learn, this is carry. That's why your answer will be 1. So this is just your understanding why and how maybe you can apply also similar how you going to remember like plus dot over here. And there is another one is after you have O, you can have not O. Not O is not O, and you have combined it as no get. No get, which is O get and then not get. So you will be having the bar over here. And similar also I mentioned, this is not going to similar to A bar plus B bar. It is totally not similar. So you can try to draw. You're going to like try to draw how the circuit look like and so on. Maybe you can like draw it using the DIT simulator. Maybe you can try to play around. DIT simulator is not big. And you can just install it into your laptop. And there is a lot of gates over there. You can like play around. It's very fun application. You play around with the value of AB and then you will get the value of X. And another one, this one is exclusive. That's why in front of the name of the get, we call it as X because it's very exclusive. Then we put it XO. XO over here, that will be like this. This is basically O. Similar to all the gates, you need to have at least 2 minimum input and you will be having 1 output only. And you need to know the condition for the truth table and what is the Boolean expression. And on top of it, let's say you have the XO, later on I will like provide you with extra notes, and you can also go through on your hard copy or soft copy module. There is like extra notes about gates. So XO over here, you can also have not XO. So it's called XNO. So this XNO is like only putting another one is bubble. And of course, there's bubble or not will be get this bar. So this is only things basic you need to know on our logic gates. After this, you just need to read about logic function. So in our logic function, it is about function only. No, cannot. Okay, it is only for function. You can see that if you compare with the module that I provide as a slide version, PDF version, it is not too many. So that's why I suggest you to read also from the text module or the ebooks that you bought, because there is a lot other information. And last time in your previous in the previous semester, the question come out from that books. Okay, so in this chapter subtopic logic function, I'm not going to do it in class, but I will record the video and I'm going to update it into our e-learning. Please make sure you watch the video, and in our next class, we will discuss only about the function. Later on, you're going to apply every single like comparison, arithmetic over here, adder, full adder. You're going to apply your gates in the subtopic in the beginning of module 1 only on the theory terms, and then theory things that you need to know. Encoder, decoder, later on you need to build. You need to build by yourself. How you going to build encoder? How you going to build decoder? Using what gates? Here is just informing you the function. What is the function of decoder? What is the function of encoder? So you just know about the function, but later on in our next module, so you will know that you need to develop and build your own calculator, your own 7-segment display, and so on. So let's say example over here, you have encoder. Encoder, you can see from the decimal. You have the decimal input. You need to convert it into binary code. The one that I showed you previously, it is from binary to decimal. How you convert, isn't it? So now in encoder, you have the input as binary. How the binary code look like? And another one is decode function, which is you have the binary as the input and your 7-segment, which is your decimal number. Okay, let's say you can see that for your calculator, you will have this display. You have a lot of 7-segment display, not only one, because you have like many numbers that you can support, right? So let's say only one display that you want to display, which is number from 0 to 9. So if let's say you want to have the 0, of course it will be look like this. So all of these have their own LED segment. So if you enable this LED, then that will be color like black, or the LED color of red will be on. So you get 0. So how you can get 0? Using what gate? Combination of what? then you can turn on this part. How about this part? How about this part, and etc. So that's why you will learn it later on. But in this subtopic, only on function. So I was like, okay, function is more like theory, what is the important, what is the advantage, and so on. So why not I just create another one video just only for function. And so you can see, if like say you want to have one display, you can like turn on only this part. If you have two, then it will be look like this. So there will be a segment that connect to this. You need to know which wire, which segment is connect to which part. So this is encoder, decoder. And then what else you're going to see? Marks and demarks. This one in your slide, the notes that I provided in the e-learning, there is very few. So please make sure you read in your ebooks and also your module books about that. And your scope, there will be a scope, right? The scope for your like test or for your exam is only from books and also in the class. If you want to have extra knowledge, yes, you can go for a Google to get the marks and demarks, but there will be no question that been asked out from notes and also module. So this one is an example. You can see also in your books there will be also question and answer. Please try to do so. And there will be also like flip-flop, another one module on flip-flop, register, flip-flop, what else? Okay, this one also you're going to learn. And counting. Okay, sometime in your project groups, you're going to be divided into several groups and you need to do a project, right? So project normally sometimes it's we like please do and create your own calculator, or maybe there will be a traffic light, or maybe a washing machine. How you going to do a system using your gates or maybe flip-flop to create all these things? Vending machine, Xerox machine, ATM machine. So from the basic gates that you learn, you can create all of these. These developer that create the traffic light, create the washing machine machines, they need to know the basic of digital logic. And then fixed function, still under function, about the IC or integrated circuit. So this is the example. You're going to see there is a deep chips and so on. So nowadays you cannot play around with this thing in your lab because you just learn it using deep simulator. But maybe after you come to UTM next semester, you can just go to the labs and play around with the this LED, these chips and so on. You can request to the technician or to the lecturer, play around with this kind of things. So in the IC package, you can see you're going to have also a pinch, a notch over here. So you're going to calculate and start your pin number using this kind of method. You're not going to like rename 1, 2, or maybe you like, it's okay lah, I want to rename the numbers, whatever I want to, but cannot. So this is the methods that need to be followed. When you have the notch like this, then it will start at this pin identifier, start 1 until 8. It depends on how many pins that you have. and then it will continue to here. Not from here jump to here 9 and so on. No. So it's going to be like anti-clockwise. But if you have different kind of IC, there is also a different way how you justify the pin number. So there is several way for you to calculate also justify the pin number. This also can be asked as a question. Pin numbering. Sometimes maybe the question asks, what is the pin for this one? So if you don't know, this is very a simple and basic question. But if you don't know and you did not read how to calculate and justify, identify the pin number, then you cannot answer the question. You lost 1 mark. The rest is, okay, this one is programmable logic device. I will share with all of you related to this video. So no need for you to worry. Any question?
No, thank you, doctor.
Okay. So if there is no more question, we can dismiss, and thank you for your participants. If you like shy, you can just WhatsApp me a question. And regarding your modules, hard copy and also soft copy, it's okay then. It's okay if I still did not reply your WhatsApp sending the receipt, because there is a lot of students still WhatsApp me, still pending payments. Unless I WhatsApp you whether you already pay or not, then it's going to be trouble. But if let's say I still not yet a reply, then it's okay. We will proceed for your books postage later on, after we combine with the what subject, discrete subject. So we will post out the books. Okay. So thank you for your participant, and please stay safe and have a good day. Bye bye.
Thank you, Doctor.
Okay, don't
Thank you,
forget
doctor.
your QR
Thank you,
code.
Doctor.
Thank you, 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 doctor.
Bye
Thank you,
bye.
doctor.